In this video, we are going to look at a simple machine. So what is a simple machine to start with? What is a simple machine? So a simple machine is just a device by means of which the force applied at one point can be used to overcome a force at a different point in a system. So a force applied at one point, so there's a force applied. This force applied can be used to overcome another force at a different point in a system. So the force applied in this case is called effort, and the force that which effort overcome is called load. So take note, these are forces, and you know that a force is measured, the units of force is Newton. So effort and load, they all in Newton. So take note of that. Okay, so having looked at this simple introduction or the definitions, let us now look at the terms that we are going to come across as we go on now with the study of simple machine. So one of the terms that we are going to come across is mechanical advantage, abbreviated as MA. So what is mechanical advantage? What is mechanical advantage? So mechanical advantage is simply the ratio of load to effort. Ratio of load to effort. Okay, and you know already what effort is and what load is. So that is how you define mechanical advantage, simply the ratio of load to effort. If mechanical advantage is a ratio of load to effort, how do you then calculate mechanical advantage? So since they are ratios, so they can be written in this form. The formula for mechanical advantage therefore is MA, which is mechanical advantage, is equals to load to effort. Okay, so this is the formula that you should take note at this particular instance. Okay, so take note of this formula, is going to be useful as we go on. Alright, so the other term that we can look at now is velocity ratio. So what is velocity ratio? So velocity ratio is in a machine or in a simple machine is simply the ratio of distance moved by effort to distance moved by load in the same time. The ratio of distance moved by effort to distance moved by load in the same time, and therefore brings us to the formula of velocity ratio. So velocity ratio is abbreviated as VR. The formula used to calculate velocity ratio is distance. I'll use distance for D. I mean D for distance. Then E, effort. So distance moved by effort multiply distance moved by load. Okay. So this is the formula that you should take note. So keep this formula as we go on in our calculations. We are going to come across questions that we are going to calculate. Okay. Now the other term that we can look at this point is efficiency. Now what is efficiency? So since we are looking at, you are going to come across different definitions of efficiency as we go on with the study in physics, as we go on looking at different topics. Efficiency, I think, can be defined in different way, but let us narrow it down to simple machine. So according to simple machine, efficiency can be defined as the ratio of useful work done by the machine to the total work done by to the total work put into the machine. It's simply the ratio of useful work done by the machine to the total work put into the machine. So that is efficiency. Now, how is the formula for efficiency? Therefore, efficiency can be calculated as efficiency W for work done by, so work done by load, that is what it simply means, divide work done by effort. Okay, so the useful work done, here the useful work done is the work done by load. So work done by load, which means you are going to multiply load multiply distance moved by load. That is work done by load. Divide, which means here is effort, multiply distance moved by effort, and this all multiply 100%. So efficiency, the unit of efficiency normally use percentages. So this is one of the formula that you can use to calculate efficiency. So in the same topic, efficiency can be calculated as so EFF efficiency is equals to mechanical advantage divide velocity ratio, that is multiply 100%. So this is also the formula that you can use to calculate velocity ratio. Okay, so having looked at the formulas or the terms, 3 of the terms that we are going to come across as we go on in the study of simple machine, let us now look at example. Okay, let us look at an example that we can apply all the terms, or that where we can solve for mechanical advantage, velocity ratio, as well as efficiency. Okay, so this is the first example that we are going to look at, and the example and the question reads, the figure below shows a ramp being used to lift a box weighing 480 Newton through a distance of 3 meters and a height of 1 meter by applying a force of, that is a force F of 200 Newton that we have. Let us put it here. So in physics, before you even start solving any question, I think it's very important you correct the data so that you take, so that even as you go on in your calculation, you have information. So that is what we are going to do. So what is the data that we have here? So the data, let us collect it. So we want to calculate, the first question is state the meaning of a simple machine. We've just defined what a simple machine previously. So when solving this question, we are going to skip question number A on this particular example. Instead, we'll move to the second question, that is calculate the mechanical advantage. So what information do we have? So a figure below, or the figure below, shows a ramp being used to lift a box weighing. So normally the weight of an object is load. Okay, so load is equals to 480 Newton. So load is 480 Newton. What about effort? Here we need to have effort. What is our effort? So if you look at this one, you're saying a height of 1 meter by applying force of F, that is force F of 200 Newton. Now the key word here, applying. So we said the applied force is called effort. So therefore our effort is 200 Newton. Okay, so this is the information that we have. We still have some information here. Now a box weighing of 480, weighing 480 through a distance of 3 meters. So the distance of 3 meters is the distance moved by effort. So this is put through a distance of 3 meters. This is the distance moved by effort. So the distance moved by effort is 3 meters. Okay, and now it is lifted. As you can see, the force is applied, pushing this box up to the top there, the distance of 3 meters. And this is the distance of moved by effort, because you are pushing this box using effort. And now when it comes here, the distance where it is here, if it is here, the distance here up to this point, this is the distance of weight of an object. And we said weight of an object is load, and therefore the vertical distance here is the distance moved by load. So normally the slant is distance moved by effort, and this is the distance moved by load. I think this is something that you need to take note of. So if you are asked to calculate If you're asked which one is the distance moved by load and which one is the distance moved by effort, or maybe in the calculations or in a question you want to correct the information and you are looking for the distance moved by load or distance moved by effort. So it's very important to take note that this slant distance here is the distance moved by effort, and this distance here is the distance moved by load. Okay, so we have the distance moved by load, which is 1 meter. Okay, so now since we have the information, we can go on and start calculating. As I said, the first question we are going to skip it because the definition of a simple machine is right here. Okay, so a simple machine is any device by means of which the force applied at one point can be used to overcome a force at a different point in a system. So that is how you define a simple machine, and that is the answer to the first question. Okay, now let us continue with the calculations now. So let us now look at the second question. So for the second question, let me put it here. So I'll put here B. The question is, calculate the mechanical advantage of a ramp shown above. So you know that mechanical advantage, we've looked at the formula for mechanical advantage, and mechanical advantage we just said is a ratio of load to effort. This is the formula. So that is the formula that we are going to apply. So here we are saying mechanical advantage is a ratio of load to effort. Okay, so load to effort. So what are we replacing on load? Load, we said, is the weight of an object, and therefore is 480 Newton. What about effort? Effort, we said, is the force applied or the force being applied, which is 200. So here is 200 Newton. And if you divide 480 divide 200, you are going to have the answer is 2.4. You know, ratios, they do not have units, so the answer is simply 2.4. That is our mechanical advantage here. Now, the next question that we are answering is that calculate the efficiency of the ramp. So now, efficiency, from what we've looked at, we said efficiency, the formula for efficiency, we can use this formula. We can use the first one, the one that involves work done by load or use of work output, divide work done by effort, which is work input, multiply 100%. Okay, or efficiency is equals to mechanical advantage, divide velocity ratio, multiply 100%. Okay, so now which one are we applying here? Do we have the work done by load? Do we have the work done by effort? Or maybe can we calculate the work done by effort or the work done by load? Okay, so now let us try out this one. So efficiency is equals to mechanical advantage, of which you already have mechanical advantage, velocity ratio, multiply 100%. Do we have velocity ratio, or can we find it? So if we are to look at velocity ratio we said is simply distance moved by effort divide, let me write it nicely. So distance moved by effort, distance moved by load. Do we have the distance moved by effort? Yes, we have it. Effort, that is work done by load, is work done by load is load multiply the distance moved by load. So the distance moved by load is 480 multiplied by, or the load is 480 multiply distance moved by load, which is 1, divide, this is multiply 100%, divide, what is the work, the effort? So the effort here is 200 multiply what is the distance moved by effort is 3. So we are going to have 480 divide, what is 3 multiplied by 200, that is 600, multiply 100%. So 480 divide 600. What are we going to have? We are going to have still 0.8. Multiply this 100, we are going to still have 80% as our efficiency. So this is how the other formula also works. Okay, so you need to look at the one that is just at the fingertip. So this is how we calculate efficiency. Okay, so this example, that is how you normally calculate efficiency. So take note of everything that I've highlighted here, more especially in terms of distance moved by effort, distance moved by load. Okay, so take note of that. So let us look at now the pulley system. What is a pulley system? What is a pulley system? So a pulley system is a mechanical device with a wheel. So we have the wheels here fixed on one hinge, okay, and rotating on the axle or shaft, and the rope drives over the wheel to lift objects, which is load. So then normally on the simple machine, also you need to take note what you are lifting. Okay, you are pulling, and of course you are lifting something. So where you are pulling, okay, where you are pulling, that is effort you are applying. Okay, so if you have a simple machine like this one, which is showing an example, of course where you are going to pull is this side. So you are pulling from this side. You are pulling from this side. So this side is called effort. Okay, and now as you are pulling, these ropes are rotating around the wheels. Okay, they are rotating around the wheels, and of course lifting what is down here, which is the load. So the weight that you are lifting here, the weight we said is load. So the weight that you are lifting here is called load. And of course where you are applying the force that you are pulling, this effort is called, where you are pulling the load, is called effort. Okay, so now this is an example that we are going to look at on the pulley system. Having explained that, let us now answer the question, the same question. We are going to answer the same question. Okay, so take note of that. So here is the first example on the pulley system. So this one is the one that we are going to look at, the first example on the pulley system. So figure 4.1 shows a pulley system used to lift a load of 9,600 Newton. So this is the load. So what did I say? Before you start calculating, make sure that you have all the information that you need. So we have already the load is indicated here. It's 9,600 Newton. Lift a load of, using an effort of, so even effort we have, which is the 2,400 Newton. Okay, through a vertical distance. So a vertical distance normally is the distance moved by load. So a vertical distance, because you are lifting this one up, and therefore this is the distance moved by load. So the vertical distance here, distance moved by load, which is the 20 meter. So that is the distance moved by load. The first question that you are finding is calculate the mechanical advantage of the pulley system. Calculate the mechanical advantage of the pulley system. Mechanical advantage, we still apply the formula that we've learned. Mechanical advantage is equals to, which is just a ratio of load to effort, load over effort. Now what is our load? Our load is indicated there is 9,600 Newton. And what is our effort? Our effort is 2,400 Newton. Now if we are to divide here, what are we going to have? That is 96 divide 24. And the answer is 4. So therefore our mechanical advantage is 4 here. Okay. Then what is the second question? What is the velocity ratio? Now on the Pulley system, also take note of this point. So on the Pulley system, the velocity, so this is our A. On the Pulley system, the velocity ratio is just count number of wheels or number of strings. So if we are to count number of wheels, how many are they? 1, 2, 3, 4, 5. So our velocity ratio is 5. Okay. Then if we are to count number of strings, here, since we are saying velocity ratio, you can either count number of wheels or count number of strings. So if we are to count number of strings, there are 1, 2, 3, 4, 5. Still 5. Count. So the velocity ratio here is 5. Now, the next question is, that is C. What is the efficiency of the Pulley system? What is the efficiency? So efficiency, we said you can either use work done by load, divide work done by effort, multiply 100%, or you can use mechanical advantage, divide velocity ratio, multiply 100. So here we can use, we have mechanical advantage, which is here. We have the velocity here, so we can use mechanical advantage and velocity ratio. And therefore, if we replace in the formula, we are going to have, since we have mechanical advantage, which is 4, divide velocity ratio, which is 5, so multiply 100. 4 divide 5 is 0.8. So 0.8, if you are to multiply it by 100, you are going to have efficiency of 80%. Okay, so our efficiency is 80%. So take note that efficiency is never 100%. So efficiency is never 100%. And of course, the reason is that some of the energy is wasted due to friction. Some of the energy is wasted due to friction. So efficiency is never 100%. There is no machine that is 100% efficient. Let us look at this example. So the diagram below shows a block and tackle pulley system used to lift a load of 200 kg. So let us have the information that we have in this question. So they are saying the load of 200 kg. What else do we have? So we only have the load. What is the first question? Calculate the velocity ratio of the pulley system in the diagram. So effort, we do not have it, but we have velocity ratio. What is our velocity ratio? It's a pulley system. We said you count number of wheels or you count number of strings. If we are to count number of wheels, there are 1, 2, 3, 4, 5. So the velocity ratio here is 5. But if you to count number of strings still, there's 1, 2, 3, 4, 5. So number of strings still are 5. So the velocity ratio are still 5. So we have the velocity ratio and load, of course. Now, what is the next question? That is B. So this is A. The velocity ratio is 5. What about B? If the machine has efficiency of 100%, so efficiency is given 80%. Calculate the effort applied. So we are calculating effort. Now, before we even calculate effort, what are we going to do? And here we are given that gravity, our gravitational field is 10 Newton per kg. Okay. So now what are we going to do for us to calculate the effort? We need to look at the formula that relates, that connects effort. So what is the formula? So the formula that we have is mechanical advantage is equals to load over effort. This is the formula that has effort in it. And therefore, for us to calculate effort, what do we need? We need mechanical advantage and we need load. Okay? Do we have mechanical advantage? We don't have. How do we calculate mechanical advantage? So let us start by having looking for the information that we can use to calculate effort. So how do we calculate mechanical advantage? Mechanical advantage, we said just a ratio of load to effort. Now, in this case, we cannot calculate. We need to find another way, another formula that connects mechanical advantage. So the other formula, since we are given efficiency, the other formula that connects mechanical advantage is efficiency is equals to mechanical advantage velocity ratio times 100%. This formula, we can use it to calculate mechanical advantage because in this case, we have velocity ratio, which is 5. We have efficiency, which is 8. Okay? So, let us find mechanical advantage. 80 is equals to MA divide velocity ratio, we said is 5 multiply 100. So, what we have here? We have 80 is equals to MA 100 divide 5. We cross multiply, we are going to have 80 multiply 5. 80 multiply 5 is 400. So 400 is equals to MA 100. We want to find MA, so we divide both sides MA 100. Even this side, we divide 100, I mean. So when you divide 100 on both sides, you are going to have mechanical advantage is equals to 4. So we found the mechanical advantage. So having found the mechanical advantage, we can go on now to calculate effort simply by applying this formula. So mechanical advantage is 4 is equals to load over effort. Now we need to find what load is. Load we are given as 200. We need to find weight simply by multiplying this one by gravity, which is 10. So we have load as 4 is equals to our. Okay, so in order for us to calculate the effort, we have the mechanical advantage here, which is 4. So in the formula, mechanical advantage is equals to load effort. We can find effort. So our effort is the one that we want to find. But the question is that what is our load? Now the load we said is just the weight of an object that is being lifted here. The weight. The mass is 200 kg. We can now find its weight. Weight is equals to mass times gravity. What is the mass that is there? 200 kg. And what is the gravity or gravitational field is 10 Newton per kg. And therefore we can find the weight, and the weight is 2000 Newton. So this is the one that we are going to use here as our load. So 200 Newton or 2000 Newton. So if we are to cross multiply, you are going to have a 4 effort. So crossing multiply here, you are going to have 4 effort is equals to a 2000 Newton. Finding effort, so our effort is 4 into 20, there is 5, so 500 Newton. That is our effort. So the effort, therefore, in this question, it was 500 Newton. Let us look at this example as the final example that we are going to look at. So figure B3.1 below shows a pulley system. The first question is state the velocity ratio of the pulley shown in figure B3.1 above. So the velocity ratio on the pulley system, we already said that you just count number of wheels, and therefore the velocity ratio is 2. The second question, if the efficiency of the pulley system was 75, what is the mechanical advantage? This one is simple. So velocity ratio is 75. What is the mechanical advantage? So what is the formula that connects mechanical advantage and efficiency? So the formula is efficiency is equals to mechanical advantage divide velocity ratio multiply 100. Okay, efficiency is given as 80 is equals to, what is our mechanical advantage, or the mechanical advantage is the one that we are looking for, the velocity ratio is 2. Multiply 100. We are going to have 80 is equals to mechanical advantage 100 divide 2. For to cross multiply here, you're going to have mechanical advantage 100 mechanical advantage 100 is equals to 80 times 2. 8 times 2 is 160. So we have 160 here. So if we were to divide both sides by 100, we're going to have mechanical advantage as, so the mechanical advantage is 1.6. That is our mechanical advantage. Okay? If the load is 120, what is the size of effort? So if the load is 120, what is the size of the effort? So how do we find the effort? Earlier on we said you just use the formula that connects effort and the load, and that is the formula for mechanical advantage. And therefore we are going to apply the formula for mechanical advantage, which is mechanical advantage is load effort. Okay, so mechanical advantage we found to be 1.6, and we are finding effort. So effort is the one that we do not have, but load is given as the 120. Okay. Now, if load is given as 120, so we're going to have 1.6 effort is equals to 120. If we are to divide 1.6, okay, so our effort is going to be, that is 120 divide 1.6. We are going to have it as 75. So our effort is 75 Newton. That is how we find it. Then the last question here is that what work is done by effort if the load is lifted 3 meters? What work is done by effort if the load is lifted 3 meters? So what we have here is that the load is lifted, so distance moved by load, the distance moved by load is 0.5 meter. Okay. What about so the distance moved, here we have the distance moved by effort is the one we don't have, but the distance moved by load, we have it to be 0.5 meter. Now, the question is, what work is done by effort? So we are looking for work done by effort. Now, for us to calculate work done by effort, we need effort as the force. We multiply by distance moved by effort. This is what we need. Okay? So in the information that we need effort and of course distance moved by effort. The question is that, do we have effort? Okay? Do we have effort? So we have load here, and we've just calculated mechanical advantage. The mechanical advantage here was 1.6. That was the mechanical advantage, and the load that is given is 120 Newton. The size of effort, the size we found 75 Newton. So we want to find the work done now. For us to find work done, so which means we are only remaining with the distance moved by effort. How do we find the distance moved by effort? So we can use the formula for velocity ratio. Velocity ratio is equals to distance moved by effort over distance moved by load. What is the velocity ratio? Is 2. What is the distance moved by effort? Is the one that we don't know. The one moved by load is 0.5. Okay? So the distance moved by effort is equals to 2 multiply 0.5. So 0.5 multiplied by 2, and the distance moved by effort is 1 meter. And now we can calculate the work done. We can answer this question. So work done is equals to force times distance. That is the work done by effort, which is effort, the force, multiplied by distance moved by effort. What is the effort? 75. Okay? The effort that we found is 75 multiplied by the distance, which is 1 meter. And therefore, the work done by effort is 75 joule. So that is the answer. Okay? So this one brings us to the end of today's class.